Do you feel the vibes?
So the plan for today is I'm going to finish this and then we can go over some homework problems as well. Okay? All right. So in example 10 here, we want to first find the type of curve. Then determine the symmetry, the zeros, the maximum R values, and so on and so forth. Okay, so this is an R squared. We only talked about one with an R squared, and that's a lemniscate. You have to know that name. Okay? Okay. So, all right. Let's talk about symmetry. Okay, so let's talk about symmetry for a minute. Okay, so take a look at the function. R is being R is R squared. It's R squared, not R. So whether R or negative R, right? That's gonna be it's like symmetric, right? So when you change R to negative R, you're gonna get the same function back. However, here it's sine 2 theta. Okay, so when you have sine 2 theta, when you have sine of theta, can you change theta to negative theta and have it equal the original? No. So the only one that's going to work is if you change R to negative R, which is which one? The polar axis. The pole. Right? So negative R squared is equal to 8 sine 2 theta. R squared is equal to 8 sine 2 theta. So this is symmetric around the pole, okay? It looks like something in the Cartesian coordinate that would be symmetric around the origin, okay? That's what it would look like. So, so do that. Okay, so now let's talk about zeros for a minute. Okay, I want to talk about zeros and I want to make it a little bit more like practical. Okay, so zeros, we're basically going to take the function and set it equal to 0, right? If you divide both sides by 8, sine of 2 theta is equal to 0, and sine is equal to 0 at 0, pi, 2 pi, 3 pi, and so on. Yes? Okay, so what I want you to do is the following. I want you to find, so 2 theta equals 0, 2 theta equals pi, 2 pi, 3 pi. So what I want you to do is I want you to find all of the points where theta is equal to 0 on the interval theta to 2 pi, 0 to 2 pi. Okay, so for example, 2 theta equals 0, theta is 0. 2 theta equals pi, theta equals pi over 2. Okay? And then where is the next one? It would be at 2 pi, right? So theta would be pi. 2 theta equals 3 pi. So theta would be 3 pi over 2. Right, and then 2 theta is equal to 4 pi. Theta is equal to 2 pi. Okay, here's what I mean. I said theta, your actual value of theta. I want you to get all of the final values of theta from 0 to 2 pi. You see what I mean? Now, somebody will look at this and it'll say, okay, it's every pi. So, you could like generate them in your mind. Show me some work, but listen, show me some work, okay? And then find all the points. So if I ask you, find all the points where this function is equal to 0 on the interval 0 to 2 pi, I want you to list all 5 of these, okay? So when theta is 0, R is 0, When theta is pi over 2, r is 0. So at 0, it's 0. At pi over 2, it's 0. At pi, it's 0, and so on. Okay, what else do we need to find here? Maximum r value. So let's talk about the radius. Okay, and where it's a maximum. So the way we talk about this is the following. My function is a sine. Sine is farthest from the x-axis at pi over 2 and 3 pi over 2, right? So sine of theta is equal to plus or minus 1 at theta equals pi over 2, 3 pi over 2, and so on. Yeah.
What did you just do?
Okay. When you just graph sine of theta, right? Over here, okay, so this is 0, pi, 2 pi, right? This is regular old sine of theta that we graphed in section 4.4. What are you chatting about over there? Okay.
He's showing me about what he's done when his hand was okay.
Okay. Not the time. Okay. Okay. Schedule a time. Okay. So now, okay. So it's 0 at 0 pi and 2 pi, right? Here at pi over 2, sine is equal to positive 1, right? At 3 pi over, don't say but. You know I'm right. Okay. Yes. But that's not what I'm saying. I'm saying the parent function sine of theta, right? Do you guys all agree with this? Just like we had said, sine of theta is 0 at 0 pi, 2 pi, and so on, right? So now, 2 theta is equal to pi over 2. Theta is equal to pi over 4. Okay, but now this is a lemniscate, right? And a lemniscate, okay, so let's see here. When 2 theta is equal to 3 pi over 2, theta, okay, just go with me on this for a minute, and I'm going to tell you something. When 2 theta is 5 pi over 2, theta is 5 pi over 4. When 2 theta is 7 pi over 2, theta is 7 pi over 4. Okay, that's in general. However, what is this function? It's a lemniscate. It's r squared equals blah, blah, blah. So if r squared equals that, what's r equal to? Plus or minus the square root of 8 sine 2 theta, correct? Okay, now, let's see. Do all of these functions work in that? Or do half of them not work in there? So when I have pi over 4 and I plug it into this function up there, I get 8 sine of what? When I have pi over 4 and I plug it in here, what do I get? 8 sine pi over 2, right? Which is a 1, right? It's a positive number. Okay, when I plug 3 pi over 4 in here, I get 8 sine of 3 pi over 2. What's sine at 3 pi over 2? It's a negative number, so it's undefined here. Okay? Okay. 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 So listen. These are the, okay. So these are the values. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, where sine would be a maximum. It would be the farthest from the axis. Okay? Now, what we are doing is we have this specific function, r squared equals 8 sine 2 theta. What we want to do is we want to find out this specific function has maxima at what points. Okay, so at what points when I graph this does it go farthest from the axis or from the pole? Okay, hang on. Okay, that's what I'm trying to find. So the math tells me you could have possibilities at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, where the graph goes out to the maximum. Okay? Now, not only do I want to find that, I also want to find how far out does it go. So why don't we do that, and maybe that will help in finding this. So my function was r squared equals this, right? So is everybody okay with, solving for r and getting that? Yeah? Okay. So why don't we take the first point here, pi over 4, and see what r equals. R would be plus or minus the square root of 8 sine 2 theta. Okay? Now, r equals plus or minus the square root of 8 sine pi over 2. Is that right? Okay, now sine of pi over 2 is 1. So this is plus or minus 8, root 8. Okay, now let's do this one. R is plus or minus the square root of 8 sine 2 times 3 pi over 4. How much is that? 8 sine 3 pi over 2. What's sine of 3 pi over 2? It's negative. So this would be the square root of negative 8, which is undefined. So that one doesn't work. Okay? What about this one? Plus or minus the square root of 8 sine 5 pi over 2. Okay, at 5 pi over 2, sine is positive 1. So this would be plus or minus root 8. Here, plus or minus 8 sine 7 pi over 2. At 7 pi over 2, so it's pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. At 7 pi over 2, sine is negative 1 again. So that would be a negative number. So this is again undefined. So what have we found? The maximum values are at plus or minus root 8 pi over 4, plus or minus root 8 5 pi over 4. Okay? At this point and at this point. So remember, this is r and theta. So when I come to graph this now, at pi over 4, I have a root 8. How much is root 8? 2.14, right? At pi over 4, okay, my radius is 2.1 and negative 2.1. Okay? And then at 5 pi over 4, where is 5 pi over 4? So it's 1 pi over 4, 3 pi over 4, 5 pi over 4. At 5 pi over 4, the radius is plus or minus root 2 over 2. It's like repeating itself, right? So those are the maximum values. Now, it's 0 everywhere else, right? So take a look at how this works. Let's do this. Look. When theta equals 0, the radius is 0 here. At pi over 4, it's the maximum. Then at pi over 2, it's 0 again, right? So it goes from here to the maximum. At pi over 2, it's 0 again. Then at 5 pi over 4, it goes back, and then back to 0, and so on, like this. Okay? So all you would have to do when you do this is graph the maximum values And once you graph the maximum values, you know it's a lemniscate. It's going to have like two poles, and you can just graph it that way. So basically, why the heck are we doing all this? Because one way of graphing these things is to pick points ad nauseum and graph this way. Another way is you figure out, okay, it's symmetric around the pole. You figure out what the maximum values are. You put the maximum values, and then you could do a quick sketch of what it looks like. Okay? It's like graphing on your feet. Okay, yes. A directional microphone was placed facing the audience from the center of the stage to capture the crowd noise for a loud recording. Okay? And then a directional microphone is just that. It's not a microphone that picks up like 360 sound, all around. It literally has like a direction from which it picks up. The area of the sound, the area of sound that the microphone captured is represented by this function, because everything having to do with waves is a sinusoidal function. And waves, when they're radiated, they don't go in like rectangular directions, right? They're radiated, so they just go like out radially, right? So that's why it's polar coordinates and not rectangular coordinates that we can use for that stuff, okay? Suppose the front of the stage faces due north. Graph the okay, so graph the polar pattern of the microphone. So first of all, okay, so this is R equal to A plus B sine theta. And notice it's 3.5, 3.5, A equals B. So A plus B sine theta, those are the limicins, right? And then A equals B is a cardioid in the limicins, okay? So we're gonna graph this one. Okay, the farthest it goes, take a look here. Take a look at the cardioids. It was too much to mention before. So this distance is 2A, right? So it would go out 7 units. Okay? Yeah. So if I go like this is 0, 2, 4, 6, 8. This is 7. Okay. So look, this is a sine, right? Before we had graphed a cosine, which was centered like on the horizontal polar axis. This is a sine, so it's going to be centered around pi over 2. So you could do, a table just like we had done before and get all the points. But basically it goes out there, and somehow I don't have the points here. Yeah, with cosine, if you look here, with cosine, it's symmetric around the polar axis. You see here? And then with sine, it's, here. Okay? It's symmetric around the poles. Okay? Okay. Yeah. So when we graph this one, okay, so at 0, okay, I want to do a quick graph, actually. You know what? Okay, when theta equals 0, how much is this? When theta equals 0, 3.5. 2, 3.5, it's over there. And it's going to be symmetric, right? So on this side, too, it's going to be 2, 3.5, somewhere around there. And this is a cardioid, so we can have it go like this. Okay? Do you see how we did like roughly a quick sketch, right? It's a cardioid. It's got a little dimple here. I put in, pi over 2, 0, 0. Now, if you want, right? I'm yelling because it's so exciting. if you want to put in like, where is sine equal to a half? At pi over 6, right? So if you want to, quickly, you should be like, okay, at pi over 6, this is a half. So this will be half of 3.5, which is like 1.25 plus this, right? That'll be like, do you see how quickly you can do that in your mind? Yeah, it's opposite to the maximum. Okay, yeah, it's opposite to where the maximum is. Okay, so that's what it looks like. So what does this tell you? If you are sitting inside the region of this cardioid, the microphone will pick up your voice. If you are sitting anywhere outside, the microphone will not pick up your voice. And isn't that the coolest thing ever? That the math says that the person sitting here will be heard, but the person standing there will not be heard. Isn't that the coolest thing ever? Come on, this is so cool, right? Huh? It overlaps a little bit because it can't ever be a rectangle, right? You can't just say, okay, nothing past this point shall pass. No, that will be a rectangle, right? Do you see how cool this is? Why aren't you guys excited about this? Look at how cool this is. The math says that's how it is, and then in reality, that's legit how it is. Because if you're here and your voice is not supposed to be heard, but it is, that means the math is wrong. But the math can't just be wrong for one problem. That means it's wrong for the entire universe, and then everything will be thrown off. Do you see do you see how much respect we need to have for this? Like, do you see how much it governs our lives? Right? Okay. Facts, dude. Slay. Okay. All right. So, so describe what the polar pattern tells you about the microphone. So basically it will pick up sound up to 7 units directly ahead. Right? So people are like, oh my God, when is this ever used? Like, look at this. You would have never dreamt that this could be used, like when you're talking about like sound and a microphone, but right? Huh? Used in stage crew, right? Like it's like literally everywhere. And it's funny how like people like complain to each other on their cell phones about how useless all of this math is, but the very device that they're using to complain about it was built by math. So it's very ironic. Okay, so and then it picks up sound up to 3.5 units on the lateral sides. Okay? All right, so let's do some homework.
Press